Okay, welcome back to Math 124.13, Section 5.1, the second video, Video B, on probability rules. Okay, here is where we left off, talking about different examples of trials. Okay, so when we're looking at these and looking at them in depth, there's a technique that we can use. So let's take a look more closely at flipping three coins. And we're going to use a technique known as a probability tree to do this. Okay, so here's a probability tree. If we have a flip 1. Okay, so here's a coin. That's a coin from the side, so you can't see whether it's heads or tails. All right, and we're going to flip this coin, and it will land one of two ways. Either heads up or tails up. Okay, but if then we flip it again, then the coin also has two options. It can land heads up or tails up. If we first flipped a tail, then we could flip it again and still get either a heads or a tails. And if we flip it a third time, there are still only two possible outcomes. If we happen to flip heads, heads, and heads again, it could look like this. If instead we flipped tails, the third time we flipped it, we would have that. In fact, this branching tree lists, when we get done with it, all of the possible outcomes of flipping a coin 3 times. And the way we read it is this. We read flip 1 was an H, flip 2 was an H, flip 3 was an H. So out here beside that last branch, we write that the outcome was HHH. Or we might look at the branch that goes from heads to tails, and our outcome would be HHT. And we can just keep going with this. H, flip a tail the second time, and then we might flip a head the third time. Okay? And if we follow that along, we would write the outcome here of those 3 flips as heads, tails, heads. Okay? And if we just keep going, we would have the following outcomes: heads, tails, tails, tail. We go down this way with the next branch. Tail, head, head. Tail, head, tail. Tail, tail, head, and tail, tail, tail. Okay, so here is a list of all of our outcomes right there. Okay, that's the entire sample space. That's all the possible outcomes of flipping a coin. And we have how many? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 outcomes in the sample space. Okay, 8 possible outcomes. That means that there are 8 members of the sample space. Of the sample space. Okay, and we can list those in other ways. Sometimes it's more convenient to do it a little bit differently. So let's look at that. Okay, so here is a collection of all of the possible outcomes, and you can see that they are all listed down at the bottom in the sample space. And look closely at this. E sub 1 has a certain definition. It is flipping 0 heads, so you could flip 3 tails. E2 is flipping 1 head. There are 3 different ways to do that. You could flip it first, you could flip it in the middle, or you could flip it at the end. Okay? But for the case of flipping 1 head, the order doesn't matter. You're just looking for 1 head to show up one of the 3 times you flip it. You don't care when. Okay? So if the order does not matter, what is the probability of E sub 2 occurring? Okay, and E sub 2 is flipping 1 head. And you can do it, if we look up here, 3 different ways to flip 1 head. So 3 out of how many items in the sample space? 1, 2, 3, 4, 5, 6, 7, 8. 8. So the probability of E sub 2 is 3/8. Okay, that cannot be reduced, so we're done with that. All right, if you do care about order, it's a little bit different. If you want to flip 3 heads for your E sub 1, okay, that's fine. If you intend for E sub 2 to be defined as flipping a head, and then flipping another head, and then flipping a tail in that order, then it is different from flipping a head, then flipping a tail, then flipping a head. Yes, there's 1 tail in each of those, but if order matters, they are very different. So instead of some of your outcomes being grouped together in these events where order matters, they're all separate. So in this case, what is the probability of E sub 2? Notice, please, that E sub 2 is defined differently. It is specifically flipping a head and then flipping a head and then flipping a tail in that order. So there's only one way you can do that. And how many are in the sample space? We still have 8 in the sample space. So in this case, the probability of what is defined as E sub 2 is only 1 out of 8. Okay, now I would like for you to notice the difference between these 2 probabilities. The probability of flipping 1 head, at least 1 head, if you flip a coin 3 times. All right, you could do a head, a tail, and a tail, a head, and a tail, or a tail, and the final flip be a head. Those are the only 3 ways that you could flip a head, flipping a coin 3 times. So there they are, the 3 possible ones. And there are 8 different ways you can flip those coins, that coin, to get 3 outcomes. Okay? Now, what is the probability, however, that you get at least 1 head? Okay, so you have this probability. Okay, how many ways can you flip 1 head? You can flip it 3 times. There it is, 3 times. For 2 heads, you could flip it this way. You could flip 2 heads this way, or you could flip 2 heads this way. So there are also 3 ways to flip 2 heads. And finally, there's only 1 way to flip 3 heads. You have to flip a head each time. So there it is. There are 3 ways to flip 1 head, 3 ways to flip 2 heads, and 1 way to flip 3 heads. You have to add all those up and divide by all the possibilities. In fact, the only way you can flip a coin 3 times and not get at least 1 head is to flip tail, tail, tail. And there's only 1 chance out of 8 to do that. Now I suggest you grab a coin and do some trials yourself, or grab a die and roll the die and see what happens, or a couple of dice. Perform some experiments. And experiments are just series of trials. Okay? Roll them yourself. Get a feel for it. And by the way, if you look at this separately and you flip a coin and it comes up heads, and you flip a coin and it comes up heads, what is the probability it will come up heads the next time? What if you flip heads and you flip heads again? What's the probability that it will come up tails? I hope you said that it's still a 50-50 chance. Its probability is 1 out of 2 that the next flip will be a head or the next flip will be a tail. All the other flips before that do not influence the third flip. So just remember that as we're moving on with this lesson on probability. Okay, let's look at what might actually happen if we do go about flipping a coin. Okay? And we're going to look at the probability of flipping heads. Okay, that's what we want to discover. The probability of flipping heads, and we go about finding that by flipping a coin. Okay, so on the left side I'll list the outcome, and on the right side will be listed the total heads divided by the total number of flips that have occurred. Okay, so let's say the first time we flip a tail. All right, if we flip a tail the first time, no heads. So total heads was 0, total flips was 1. So 0 divided by 1 is 0. Okay, so we flip the coin again. And this time we get a head. So we got a total of 1 head out of 2 flips. So the probability to that point, the way we're doing this by experimental probability, is 0.5. And then we happen to flip another head. See, there's the coin still flipping. All right. 2 heads out of our 3 trials. We have an experimental probability of 0.67. Wait a minute, that's more than the 50% we would expect. Why is that? The laws of probability, so true in general, so fallacious in particular. Another way to say this is that it's called the law of large numbers. As the number of trials of a probability experiment increases, the proportion of time an outcome occurs approaches the probability of that outcome. In other words, on small scales, probability isn't very reliable. You can't predict what the next roll of a die or the next flip of a coin will be. But over time, you can predict that approximately half of the flips of a 2-sided coin will be heads and half will be tails. In fact, here's a cumulative probability graph for flipping heads. And in this case, if you take a close look at it, you'll see that the first coin was a head. Looks like the second coin was a tail, which would give you a 50% probability, but the next coin was a tail again. Oh, but then you had a head, and then another head, and it goes on, and it approaches 50% as you continue on infinitely. Okay, so empirical probability, that's what this process is by actually flipping the coin and seeing what happens, rather than just thinking about the possibilities. Okay, so in empirical probability, it's approximately the relative frequency of an event. So if you take the frequency an event occurs over the number of experiment trials, you will get the empirical probability. Okay, and once I'm going to have to leave you here, I have a little bit more to talk with you about, so that will be on our 3rd video. All right, so look for video part C.